Greetings, friends. Randall Nagy here. Welcome to our second installment of our Advanced Python Training Opportunity. As you remember from our previous example, we demonstrated how we could create, read, update, delete, as well as search something using a very easy dictionary, which will allow the user to select either CRUDS or Q in such a way so as to allow our options to grow easily by putting function definitions into our dictionary, which can be accessed by the key that the user will select, so as to use a very simple loop to select the options as well as to execute that function when required. While an interesting demonstration in its own right, it was a very useful. And in this demonstration, what we're going to do is show you how to create an application that will allow you to collect data without changing these signatures very much at all. Switching over to one of my favorite design tools, or Argo UML, at this point we should note that we have done little more or less than cover the basics of how we can substitute and grow a list of function pointers or function classes in Python to cover our basic operations. An interesting enough pattern in its own right we haven't really talked about is what are we trying to manage using the CRUD plus S pattern. Once we understand that we're going to be searching and managing records, of course, we're free to use any underlying technology to manage our records, or rows if you would, and for the purposes of this edition, we're going to be using JSON, but we'll be using SQL and other technologies later on. Noting that we're going to change the name of our file to ADV02, we update both our source code and diagram to help us keep track of the differences. Of course, the first thing we need to do whenever we're working with JSON, or JavaScript object notation, we have to import from the core Python support the JSON package. Once imported, of course, we need to talk about what type of data we're going to be saving or serializing using the JSON object reader and writer. Once again, relying on Python's dictionary will give us our basic record format, starting out with our simple name, address, and phone number. We can once again use a for statement to assign the user input to our dictionary. Enjoying our wonderful F string means, of course, that we're using a version of Python greater than or equal to Python 3.6. And in a like manner, we should note that with the advent of Python 3.7 or greater, we no longer have to use ordered dict so as to ensure the proper ordering of our keys and value pairs, but rather the default behavior of dict or dictionary is to maintain key value pairs in the order of which they have been provided. Now that we can enter our name, address, and phone directly from the keyboard, as well as asking the user for each one of those key values, we can replace the none with whatever the user inputs, ultimately to create a file based upon the name provided by our user. Finally, availing ourselves of the familiar syntax, of course, we can open our file so as to overwrite or create it, and then use JSON's dump capability to dump our dictionary, known as record, into that file handle. Testing our create operation, we can enter in a name, in this case my name, real email address, as well as a real phone number, because spammers don't necessarily utilize the ability to get text from pictures from geeky videos. And moving over to my local directory, we see that I do indeed have a file that matches my first name with the .json extension. And in that file, I do indeed have the data formatted in what looks like a Python dictionary, but of course is actually being saved in the JSON format. So while we can create something and verify it manually by opening the file, and of course the beauty of JSON being that we're using a string format that we could modify on the drive, in order to verify the next step, all we'd have to do is load what is on the file. And inasmuch as we have used the dictionary value of name, the record reading scenario here is simply that the user selects the name of a file to load. And because we're going to want to read over and over and over again, perhaps a good policy would be to allow whatever the user select to be returned to us as a dictionary, otherwise to return a null. Now, because we're going to be using the name many times to create our file, perhaps the best thing to do at this point in time would be to create a function that all of our CRUDS can reuse so as to create the real file name from any string value, in this case, whatever the user enters in for the name, which as we saw in our create function, we are indeed using as the name of our file. Easy enough to create, of course, as well as to reuse in our create function, as well as our read routine. We should probably check to see if the file can be found on our hard drive. In order to check to see if our files can be found, of course, we're going to want to import os.path, and because we're going to probably want to delete that file later on, we can go ahead at this point in time and import os as well, which will give us our deletion functions, and of course path will give us the ability to check to see if a path name exists. We can check to see now if the path exists for the file, and if the file does not exist, we can print out our message. Once again, using our if string, providing our variable, and saying that we have read nothing or none. However, if the file does exist, keeping in mind that we're going to have a JSON file type, we can get our record or our dictionary read back in using our JSON package or module to load that file handle. And just for debugging purposes, we'll go ahead and print that record before returning the record, or once again, if things go wrong, knowing that we will throw an exception, we'll go ahead and just make sure that we tell everybody that no matter what happens, as we enhance our code in the future, we're going to return none. Running our program, we can read our previous data and verify the contents, as well as making sure that our operation succeeded. Creating another record, we can once again read Jasper and see that no matter which we read, all is well. Now, as we operate our ADV02 Python program, we notice they can be a little annoying simply because we might not remember what we have previously entered. We may want to be able to add another aggregate function in addition to searching many records. That's while we have the est. Of course, we might want to list those records as well. As we saw in our previous example, it's easy to extend the operations to include something like an L to do a list. But you notice the syntax here is going to say, look, I don't want to execute the list built in so as to give me a mutable list. Instead, what I want to do is to call a list function. And while Python recommends in PEP 8 that we do something like this so as to create a new tag, personally, the guidelines rather than rules, and inasmuch as Python does indeed say that a foolish consistency is the hobgoblin of little minds, we'll go ahead and simply create something called list F, which probably should introduce us to another capability, which will allow us to use the os.listDirt to list every file in our directory, and knowing that we're going to get a string back, we can use the ends with to check for our JSON, and to keep things short, we use the negation so as to simply print out another F string that will remove our suffix. Once again, remembering, file is a string. We're going to use the built-in replace capability to replace our .json suffix with an empty string. Running our application, of course, we see that when we press L, we now list our two files that we previously created, and we can read them as well, or create yet another one to see that everything can indeed be listed as we'd expect. Well, so far so good. What we haven't put together yet would be our search, our delete, and our update capability, and we'll be covering these new functions and features in the next session. If you'd like to know more about either beginning, intermediate, or advanced topics, I'd invite you to go ahead and peruse and use one of my Python 1000, 2000, or 3000 training opportunities on Udemy. Thanks for watching, and I'm looking forward to seeing you in the professional software development world.